Stacks and queues are specialized collections that govern how items are added and removed from the list. Let's start by looking at a stack, and we'll make it a stack of int items. When we want to add an item to the stack, we are going to push a value, such as the number 1. We could add another element, 2. Then we can push another element, 3. Now the interesting thing about the stack is when we add these items, you can think about it like adding a stack of coins on top of a table. So when we added the first one, 1, that would be the one immediately touching the table. Then we add the coin number 2 that goes on top of 1, and then the coin number 3 goes on top of coin number 2. Well, it's probably not a good idea to try to remove the coin at the bottom of the stack because you topple over the 2 coins on top of it. So the stack data structure also allows you to remove items, but in the exact opposite order that they're added. Let's create a method called print stack that accepts a stack of ints for each item in stack. Let's go ahead and print that item out. We could do a console write. And then that will be item inside curly braces, followed by a space, and console write line. Then we can call print stack, passing it the stack variable. So let's print this out, and you will see the items are printed in the exact opposite order we added them. So the first item printed is 3, then 2, then 1. So 3 represents the top of the stack. So when I retrieve an element, it's called pop. And I can take that value and stick it in a temporary variable called pop. And then I will show what that value is. So when I pop a value off, it is the 3. I didn't reprint the list, but if I did, then you'll see the list contains only a 2 and a 1 now. 2 and 1. I could pop 2 off, and then I could pop 1 off as well. If the list is empty, the stack is empty, I do not want to attempt to pop a value off of the stack, as it will throw an exception. Since we don't want an exception, we should probably test to make sure that the count of items in the list is greater than 0 before we call the pop command. If you just want to take a peek at the top element in the stack, you would use the function called peek. Again, should probably make sure that there are actually elements in the list before you issue a call to peek. So peek will allow you to see what's at the top of the list without actually manipulating the list itself. So after I do the peek, I will print the list again just to prove that the list has not changed. So it's 3, 2, 1. We pop off the 3. We're left with 2, 1. When we peek, we see the 2, which is at the top of the list. When we reprint the list, it's still 2 and 1. A queue is very similar to a stack, except instead of adding and removing items in what is known as LIFO order, or last in, first out, it is going to be in FIFO order, which is first in, first out. So a queue kind of represents like a line of people waiting for a bank teller. Let's wrap all of this inside of its own method. Call it stack stuff. Let me fix that T here. And then I'll create another method called queue stuff. Queues are built in a very similar manner. It is a generic queue. However, the commands to add or remove items are different. It's not push and pop. It's going to be enqueue and dequeue. So I could say queue.enqueue, the value 1, queue.enqueue, the value 2, queue.enqueue, the value 3, and I can again print the items with a specialized method. So instead of print stack, I will print queue, and this will be a queue as well. I'll rename this to queue, but otherwise it's going to do pretty much the same thing. So I'm going to comment out the stack stuff so we only see the results of the queue operations. And there it is, 1, 2, 3. Notice we added 1 first, then 2, then 3, so it's printing like a regular list would. The biggest difference between this and a regular list is we don't access the elements by index, just like stack, and when we pull elements out, it pulls them out of the head of the queue, or the first element added is always the first element removed. I'm going to copy the if statement we used for the stack, because we should, once again, make sure that the queue has not exhausted its elements when we try to retrieve something from it. And as I mentioned, it's not pop anymore, it's dequeue. I'll just call it D, the little letters D and Q, to indicate we have dequeued an item. That's the variable. And then I'll print the queue again, and it should show us that 1 is removed from the queue. So pretend these are customers in a bank. They walk in line. Customer 1, 2, and 3 are waiting. A teller becomes available and helps customer 1, and now 2 moves up to the front of the list, followed by 3. Additionally, the queue collection also supports peeking, and it's the same peek method that stack uses. So if you just want to check what's at the front of the queue, you can call peek without the risk of removing the item as well. So what are these data structures, the stack and queue, good for? The stack is very frequently used in computer science. As a matter of fact, we have a data structure in C# called the stack, which is used to store value type variables, as you may have heard in many other videos. But besides that, a stack can be used when you are doing traversals. Like, say for instance, you have a maze that you wish to go through. You can use a stack to indicate the path you are taking and store the possible directions that you can go when you reach an intersection. And by putting the elements in the stack, you're giving yourself the ability to recall those items when one of the paths reaches a dead end. Then you can backtrack to the previous item by popping that location off of the stack. Queues, again, can be extremely useful in computer science as well, especially for file or data processing. If you need to make sure that items are processed in the order in which they're received, the queue is a fantastic data structure because the first item into the list is always the first one that comes out. So if you are creating something that processes files on a file system in the order they're retrieved. You could have something, some kind of program monitoring a directory, and as files are added, you add that file name to the queue, and as CPU and I/O resources become available, it'll process the items in the order in which they were added.